I am HMPHP Paranagama. My registration number is ID 20643140. For SSD module, website security assessment assignment, we have selected online hotel management system for the testing purposes. And in here, in this application, for the front-end development, we have used React.js. For the back-end development, we have used Node.js. For the database connection, we have used MongoDB. And for the front-end and back-end integration, we have used RESTful web services. Using the MERN stack, we have developed online hotel management system. And using this application, we are going to test vulnerabilities. For testing purposes, we have used two uh, two two open source applications called OWSP Zap and the Sync tool. And in this application, we have added an extra feature called authentication. That means we have provide a Google sign-in option for the users when they log into the system. In this application, we have identified 8 vulnerabilities, and we are going to correct those vulnerabilities. The first vulnerability that I was identified is allocation of resources without limit or threatening. This is a serious security problem that may affect the functionality and the dependency of the software system, because it will the malevolent actors will leads to the excessive use of system resources like CPU, memory, network bandwidth, like that. So we have to correct this vulnerability. And in this SS screenshot, it shows that we got this vulnerability during our vulnerability testing. And we are going to fix this vulnerability using the customer login interface. Before fixing the bug, the customer login interface was coded as follows. To correct this vulnerability, we have added a node module dependency called express rate limit. And in the uh, login code segment, we have added this login limiter constant function, and then it is added as a parameter in the router host for the login function. uh, and the second vulnerability that I was identified is information exposure. It means a security hole in the computer system or the software program that enables unauthorized access to the sensitive, confidentially information in the website. And this is the proof that we got this vulnerability during our vulnerability test. And before fixing the bug, this is the code segment that we can show to you. And when we fix in the bug, we have added a node module dependency called helmet. And for the solving the vulnerability, we have added this helmet as a const variable, and then we have use this dependency for the solving process. That's all for the vulnerabilities that I identified. Thank you.
I'm DDRSS Hettiarachi. My registration number is IT 20641238. The first vulnerability which I was identified is cross-site request forgery vulnerability, where a user unknowingly sends the unauthorized request to a trusted site. This vulnerability I identified using SNIC tool. To mitigate this vulnerability, I installed CSURF dependency and add content security policy. Middleware helps prevent unauthorized scripts. Here's the screenshots before fixing vulnerability, and this is after fixing vulnerability. And here I install CSURF dependency, and here I use it in this API. And the second vulnerability that I was identified is cross-site scripting. DOM access is a type of XSS where client-side scripts maliciously manipulate the DOM. Unlike typical XSS, DOM access attacks occur exclusively on the client side, making them harder to detect. Using DOM purified dependency, ensure the client-side data manipulation can't execute malicious code. It sanitizes input from a React use state value flows into a script SRS attributes. Here's the after fixing code, and this is the DOM purify dependency I add.
My IT number is IT 206-50070. So the vulnerability that I'm going to deal with is the missing anti-click check-in header vulnerability. It is a type of vulnerability which occurs when the extreme option header, security header, is not configured properly or not implemented even. So this kind of attack typically happens when a user try to click on a specific area of the website, like something like a button. So this attacker will use the iframe invincible layer on the website, so it will direct it to somewhere else rather than the desired location set by the user. So that's how this attack will occur in a web application. So in order to mitigate this one, so we have to correctly implement the extreme option header in the website to mitigate this vulnerability. So this can limit how the content will be embedded through the iframes on the website. So the application that I've selected is a MERN application. This project that we implement in the for the ITP models. So I have modified this code by adding a content security policy middleware, and through that I able to mitigate the vulnerability. So after applying this fix, so when I run the dynamic code scanner, is help me to verify that this vulnerability have been resolved by this fix. So that's all from my end. Yeah.
Hi, I am Amanda Namaswamy. My ID number is IT 20 66455. So firstly, I have identified the unvalidated input vulnerability. So it's a security weakness is a software application that occurs when the application is when the application doesn't properly validate or sanitize data from the external sources such as using inputs or data external systems. So in order to avoid this vulnerability, so we can validate all incoming data to ensure it to meet expected criteria. So as an example, data types, length, and formats. So we can reject any data that doesn't meet these criteria. So this is fixing code. I have do the implementation, and another one is not rate limiting vulnerability I have found. So as an example, imagine when a web application is allowed to user to submit login attempts without rate limiting, so attacker can submit result so attacker could repeatedly submit request very fast rate and trying to guess password until the succeed time. So it's not a good thing. So we have to fix it. So I implement the rate limit. So I define rate limiting rules. Each critical acceleration, this includes the specifying the maximum number of requests allowed within a certain time frame. So this is the code I have used to avoid this vulnerability.